So 9.2 talks about special right triangles. Now, some of you guys are going to love this because the whole idea of this is that we want to take shortcuts. We want things to be very quick. We want to find the answer without doing much work. You don't hear math teachers saying that very often, right? The idea is we do not want to have to show work. We want to just take shortcuts on a 45, 45, 90 or a 30, 60, 90. Now you might say, well, what are those things? Those are the two special right triangles. The first one, again, is called a 45, 45, 90 triangle. And they call that based on the angle measures. Okay, the angles are 45 and 45 and 90. And the shortcut to find the side lengths of a 45, 45, 90 is given by this shortcut, okay? If these two angles are 45 degrees, the sides across from them are always the same, okay? It's called isosceles, meaning those two sides have the same length, no matter what. If it's a 45, 45, 90 triangle. And then this third side here is always the measure of one of the other legs times the square root of 2. Okay, and then notice also that this third side, that's the hypotenuse. Okay, so the hypotenuse is always one of the legs times the square root of 2. So here's how we use that to find side lengths. It's going to be quick. There's not going to be much work. So just watch up here because it's going to take like 2 seconds to do this problem, okay? If this is a 45, 45, 90 triangle, if this leg is 10, this one is also 10. And the hypotenuse is that leg times the square root of 2. And we're done, just like that. Okay, again, the two legs have the same measure. And then the hypotenuse is always the leg times the square root of 2. Okay. And that's for a 45, 45, 90. Okay, so like part B, this one gives us the hypotenuse is 6 root 2, which means the legs have to be 6. So that side 6 and that side 6. Done. Simple, no work. Okay, so again, this is about shortcuts. Now we could do Pythagorean theorem. I mean, like in this other problem here, we could have done 10 squared plus 10 squared equals c squared and did all that stuff. But the idea is to use these shortcuts, but that only works when the angles are 45 and 45 and 90. All right, so let me draw a 45, 45, 90 triangle right here. So let's see, let's go to the left here. Let's make it look like this. All right, give me a number between 1 and 100. 100. All right, so let's say that this is our right angle. Okay, so we should then know that this is the hypotenuse, right? And let's say that this is 45 degrees, which means this has to also be 45 degrees because they have to add up to 180. And somebody said 100. So let's say one of the legs is 100. Take 15 seconds to find the other leg and the hypotenuse. If it takes you more than 15 seconds, you're probably doing it wrong. Here we have this right triangle. One leg is 100. That means that the other leg has to be what? It's got to be 100 also, right? It's got to be the same thing. And then what's the hypotenuse? 100 root 2. Done. Okay. So that's our shortcut for 45, 45, 90 triangles. Not so bad. All right, any questions on that before I move on to a different type of triangle? Because there's one other special type of triangle that we're going to talk about. So let's scroll down here to what's called a 30, 60, 90 triangle. Okay, and there's only two special right triangles we're going to work on. Those are the only two. The first one and then this one. So for 30, 60, 90, because the angles are three different measures, the sides have three different measures also. So like in the other one, we had two sides that were the same. We don't have that in this case. What we do have is we have what I'll call the short leg. Since this is 30 degrees, it's always across from the short leg.
Where's the N on the solution problem?
The N on the solution problem?
There's no N on it. There's only an X and a Y.
I'm sorry, which one? Oh, you're getting ahead of us here. Just give me a moment, okay? So we have across from the 30 is the short leg. Across from the 60 is the long leg. And then we have our hypotenuse. And the relation is that the short leg is always half the hypotenuse. Those two are kind of the easy ones to work with. The short leg is always half the hypotenuse, or the hypotenuse is twice the short leg, however you want to look at that. And then the longer leg is the short leg times the square root of 3. Okay, so I usually suggest finding the short leg and the hypotenuse first, if you can. And then the long leg is the short leg times the square root of 3. So, for example, let's take a look at this problem down here. Now, I'm going to change this a little bit. See where it says 12? Would you write 12 square root of 3 next to that, please? So, looking at the 12 square root of 3, that's our long leg. That's like that guy, okay? That's our longer leg, which means our shorter leg is just a number in front of it, the root 3. So the shorter leg is going to be 12. And then the hypotenuse is twice the shorter leg. So that's going to be 24 because it's 2 times 12. Okay, so you might hear the jingle x, 2x, and x root 3, or n, 2n, n root 3. Okay, that's what that means, is that our short leg is an x, a number. The hypotenuse is twice that number, and the longer leg is that number times square root of 3. So a little bit more work with the 30, 60, 90s. But let's try another one together. All right, so we have this 8 here. So the first question you want to ask yourself is it the short leg? Is it the hypotenuse? Or is it the longer leg? Which one is it? Look at the right angle there. So yeah, it's a hypotenuse, okay? So the 8 is the hypotenuse. So the relation between the hypotenuse and the short leg, which is always across from the 30, that the short leg is half of it. So x is going to be 4. And then that means the long leg is the short leg times the square root of 3. Okay, now we're done. All right, so now below there, we have a couple of example problems. But now they're mixed up a little bit. So first, you got to look at the first problem and say, okay, that's a 45, 45, 90. Okay, that's like the first stuff that we were doing. And the 45, 45, 90, these two were the same. This was the number times the square root of 2. That means that both of those sides have to be 4 and 4, since this is 4 root 2. And we're done. So why don't you take 10 seconds to do problem number 2? If it takes you more than 10 seconds, you're approaching it the wrong way. It's a 45, 45, 90. We're given that one of the legs is 3. That means the other leg is 3. The hypotenuse is 3 root 2. Okay, so the question was, why aren't we using the square root of 3 thing? You first have to identify what kind of triangle it is. Because the angles are 45 and 45 and 90, that means we're doing this thing. Okay, so we're using where the two legs are the same. And remember that because the 45s are the same. Okay, so you're going to have two sides that are the same. All right, good question. So looking at it, now this one, problem number 3, that's not a 45, 45, 90, it's a 30, 60, 90. So now we are going to do that, one with the radical 3. So in that case, we're given the longer leg is 4 root 3. That means the short leg is going to be 4. It's going to be the number in front of the root 3. What's the hypotenuse? It's double the shorter leg, so it is. Yeah, going to be 8. Very good. Getting it? All right, I have some more practice for you guys, but are there any questions yet?